So, inverse it is. Verifying inverse. All right? The inverse composition rule. If I take f of g of x and I simplify it, it ends up simplifying to just x. Okay? And I switch them around and take g of f of x, and that also simplifies to just x, then that means the functions are inverses of each other. They both need to simplify to x, and that means they are inverses of each other. So, we have two functions here, for example, 5. Show algebraically that f of x equals x cubed plus 1, and g of x, which is the cubed root of x minus 1, are inverses. All right? And I can do that using the inverse composition rule. So, I'm going to start out with f of g of x and see if that will equal just x. Okay, first of all, an f of x function is x cubed plus 1, right? Well, what am I putting in there? I'm putting in there g of x, right? So I'm going to say f of g of x, which is the cubed root of x minus 1. That's g of x. I'm going to put that into the function x cubed plus 1 and see what it simplifies to be. All right? So let's do this. I'm going to put this in for x. So I've got cubed root of x minus 1 cubed plus 1. What's the first thing I do? Yes, they do.
So then you just left with the x plus minus 1 on the right.
Right. Hold on. The radical cube root and the cube cancel. So I'm left with x minus 1, and I still have my plus 1. Now what can I do?
That's not 1.
And what am I left with?
X.
So guess what? F of g of x does equal x. That's our first one. But that's not enough. I've got to flip it. I got to take g of f of x, and that should also equal x. Okay? And if that happens, then I've just shown algebraically that they are inverses of each other. So, I've got g of f of x. Now, the function g of x, we know that is the cubed root of x minus 1. Same thing, I'm going to put f of x into it. This is f of x, all right? So I'm going to take g of x cubed plus 1, because that's what my f of x is. And I'm going to plug that into this function, the cubed root of x minus 1. So here we go. This will go in for my x. So I've got the cubed root of x cubed plus 1 minus 1. What's the first thing I do for simplifying terms? They cannot, because the cube isn't by itself. Right? If it was a perfect cube under there, I could.
Can you distribute the negative 1? Within the radical or not?
No, because I'm not multiplying by a negative 1, I'm just subtracting 1. So, if I have parentheses here in my expression, and there's nothing I can do with them, that is simplified. So now, whatever's in this parenthesis, I can now subtract 1 from. So I can basically just rewrite that. I'd say that, well, that's x cubed plus 1 minus 1. Isn't it? It's the same thing.
So then you'll get x cubed inside the radical plus cubed root, and then the cube is canceled.
Yes, it will. Yes, it will. These will cancel, and I will get this now. The cubed root of x cubed. And you are absolutely right. The cube and the cube root cancel. So g of f of x is also x. So they are inverses. That's how we can solve it. They are inverses. Yeah, so what that means is that if I were to take the inverse of one of these functions, if I were to take the inverse of one of these functions, it would end up equaling the other function. All right? Now, some people say, oh, listen, do I really got to memorize that? What if I just switch x and y and solve for y for both of them and they end up being the same thing? Each other. That's fine. For example, and this isn't in your notes, you don't have to write it down, I just want you to follow. Okay? What some people have asked me is if I know f of x equals x cubed plus 1, can I just take the inverse of this and see if it equals g of x? Like if this is a y here, can I just switch my x and y and solve for y and see if it's the same? You can. That's algebraic proof.
So, what you just said, we can do the same thing, but your inverse is equal to g of x.
Yeah, like, so this right here. Say I don't have one function. Say I just want to find the inverse of this. Can I switch the x and y and solve for y?
Yeah.
Well, you say, well, why don't I just do that to my f of x function, and I can do that to my g of x to see if their inverses are each other. You can do that as well. Okay, it's another method. Like right here, when I switch the x and y, I would say x equals y cubed plus 1. All right? I subtract 1, don't I? Yes, you see what I'm saying? So I got x minus 1 equals y cubed. And I need to solve for y, so I want to take the cubed root, right? So I've now got the cubed root of x minus 1 equals y. That is the inverse, right, of x, which is g of x. Yeah. And then I can do the same thing for g of x. Take the inverse and it ends up being f of x. So, I mean, if you want to remember less things, you can do things that way. There's no shame in doing it that way. It's algebraic proof.